Let us solve a utility maximization problem. We have maximized the utility function. Utility is a function of the consumption of two goods x and y, which are related like this: 4x square plus 3xy plus 6y square, subject to the budget constraint that the consumer is facing, which is equal to x plus y is equal to 56. The prices of x is 1 and the price of y is also 1, and total income of the consumer is 56. Okay, so that our question is to maximize the utility of the consumer given the utility function 4x square plus 3xy plus 6y square, such that x plus y is equal to 56. Here the price of good x is 1 because the coefficient of x is 1. Price of good y is 1 because coefficient of good y is 1. That is, we have the price of good x is equal to 1, price of good y is equal to 1. Okay, so let me draw a simple graph here. We have good x on the horizontal axis, good y on the vertical axis. Let us draw this budget line. Okay, with the given budget line, or with the given budget, consumer wants to achieve highest satisfaction. Okay, so highest satisfaction will be achieved where the indifference curve and budget line are tangent to each other. Okay, so what is the slope at the point of tangency of the indifference curve? Slope of the indifference curve is simply the marginal rate of substitution, MRS, and we equate with the price ratio, that is price of good x upon price of good y. Okay, so at optimization or at equilibrium, marginal rate of substitution between good x and y should be equal to the ratio of the prices of good x and y. Okay, now MRS is simply the ratio of the marginal utility of good x and marginal utility of good y, and it should be equal to the ratio of the prices of good x and price of good y. MUX means the marginal utility of good x, that is the change in the utility due to the change in the units of good x consumed. Likewise, marginal utility of y is the change in the utility due to the change in the consumption of good y, that is the partial derivative of utility function with respect to good x, partial derivative of utility function with respect to good y, this ratio, and it should be equal to price of good x upon price of good y. Now du upon dx means the partial derivative of utility function with respect to good x, and let's take the derivative here. So derivative of x square is 2x, so 2 into 4 is 8, we get 8x plus derivative of x is 1, so we are left with 3y, and derivative of this term is constant because we are taking derivatives with respect to x, divided by du upon dy means taking derivative with respect to y. Derivative of the first term is 0 because we are taking partials with respect to y, it is assumed as treated as constant. Derivative of y is 1, so we are left with 3x plus derivative of y square is 2y, so 2 into 6 is 12y, and it should be equal to the ratio of the prices. Price of good x is 1, price of good y is also 1, which is equal to 1. So do the cross multiplication here. Okay, and let me rub this out now, which implies 8x plus 3y is equal to 3x plus 8y. Now transpose this x here, this y here, so we get 8x minus 3y is equal to 8y minus 3y. 5y is equal to, sorry, here we have 3x, so we have here 8 minus 3, 5x, so I have done a mistake here. We have 8x plus 3y. Doing cross multiplication, it is equal to 3x plus 12y. I have written 8y here, so transpose this here and this there, so we get 8x minus 3x is equal to 12y minus 3y. Okay, so it is 5x is equal to 9y, or x is equal to 9 upon 5y. Now plug this value of x into the budget constraint here. So in place of x we have 9y upon 5 plus y is equal to 56. Okay, so do cross multiply. We have 9y plus 5y, which is 14y upon 5 is equal to 56. Implies y will be equal to 56. Transpose 14 upon 5, it becomes 5 upon 14. So 14 ones are 14 fours are 56. So 4 5s are 20. So y will be equal to 20. Consumer will consume 20 units of good y, and x will be equal to 9 upon 5 times the value of good y, which is the units of good y which we calculated. 5 ones are 5 fours are 20. So it will be x will be equal to 9 fours are 36. So consumer will consume 36 units of good x and 20 units of good y to maximize utility. I hope I make myself clear in this video. Thank you.